In this particular case, I've got a meter measuring the actual loss that will be achieved during the splice. So we'll now break the fibre, insert a heat shrink sleeve, prepare the fibre end, 25mm strip, wiping clean with fingers to remove excess acrylite, rotating the fibre several times backwards and forwards, cleaning the glass so it's squeaky clean, aiming for 11mm cleave. Place the fibre in the machine without the fibre end touching anything and just shy of the centre. Prepare the second end. Cleave again, 11mm. Placing the fibre in the machine just shy of the middle. It is in auto mode, so it'll feed and splice provided cleave angles are good. We have the loss, slide the, and that can be compared up on the screen. We also have a full readout of all the parameters to do with bend, step, mode field diameter mismatch. Let it go through a tension test. The order will be is the completion of the tension test. Slide the heat shrink into position, center, it's now going through its heat shrinking phase, and while that's occurring we can prepare a second fibre. Goes through the cooling phase, lift it out of here, put it into the cooling tray and continue working. So in here we have all the information regarding what type of fibre was spliced, time, date, plus we also have an image of the splice from the X and Y camera. We also have the cleave angles and whether there was an error or not. All this information can be stored onto the USB thumb drive if it's installed in the machine. There's a touch screen, so whatever you need to see on the screen you can bring up, change programs and change views, and also tap to zoom. We haven't got a fibre there. We'll put one in. We'll do another splice. So this time I'll put the machine into a pause mode so you can see it go through each of the steps. I'll break it, put a heat shrink on it. These heat shrinks are easy to maintain on the machine with its easy to use menu adjustment for the heat and time. time I'll put it into a pause mode. Change it to step, overwrite. It'll bring it in and then it'll pause at each step. So now we can check the cleave angles, 0.6, 0.6. Total angle 1.29. One of the curious things about the fibre is that if you rotate it, so where there was 0.6 and 0.6, I've now rotated it about 90 degrees. So now it's 0.5 and 0.5, but the total is 0.1. So that's just by orientating the fibre. Not that you would normally do that, just out of interest, so you understand the left and right angle and the fact that they come up with a total. Excessive total is going to give you a poor splice.
What's an excessive total?
4 degrees.
What's an ideal total?
Ideal would be, like perfect would be less than 1. Excellent is less than 2. This is your combined angle. And combined angle of 3 is still going to be fine. We've actually done tests and taken it up to 6 degree total and still ended up with below 0.1 dB loss. So on core alignment machines on single fibre, it's easy. So we've got X view, Y view, X and Y vertical, X and Y horizontal, and each one of these allow you to zoom. So from here we can hit the play button. It'll go through the splice and then it'll give us a set of readings. So the reading there is 0.01. These are a calculation based on the geometry. As you can see on the machine, the splice loss. Let me just untangle the extra pressure. Yeah, it's similar. So we typically end up with a lower loss in actual fact against what the machine is displaying.
So the machines are somewhat conservative.
There are some machines that will tend to show you 0 all the time, and they've just designed their calculation to be on the favourable side. It makes the machine look good and it makes the splicing look good, but you end up having to go back and do rework. We like the idea that we're showing a negative view, so the technician, when he can look at the image, he can just decide whether that's a good splice or not. So if the technician is looking, he can zoom in on the actual fibre and get a good clear view, and he can decide himself whether he thinks it's lined up properly. In this particular case, we have a very slight step, so it goes step, bend, mode field diameter mismatch across the first 3 figures there. If it's a mode field diameter mismatch, it's not going to change. It doesn't matter how many times you break and resplice it, because it's 2 mode field diameters. If it's a bend or a step, you can break and redo it and get a better result, or a worse result, depends on the splice. So we'll let it go through the tension test now. We'll slide the heat shrink up, get the heater ready. At the time that you do the splice, the heater is preheating, and by the time you close the lid, it's already got some heat into the machine. Oop. That was closing the lid in an auto mode. So there's the heater running. Pop it out of here and let it cool. We're ready to do another one. The other thing that I'll show you while we're in here is the tools and the heat shrink adjustment. So here we can see flared, bubbles, overshrunk, and if you have a problem with your heat shrink and it looks like one of these, what you do is you hit that, it'll automatically adjust the program to bring it back into line. And so the next heat shrink should end up looking a nice evenly shrunk down area. The other area that you can edit is going to be in here. We have a choice to select or edit. So if I go into edit, I now have the opportunity to actually edit the parameters of the heat shrink program. So the heat time, the temperature, and this is under the advanced settings. We have a lot more detail. We don't recommend that you get involved with that. It's sufficient for you just to change the time or the temperature to achieve a result if you want to be working on it. A very interesting function that this machine has is a function called curl remove. So in curl remove, we're going to swing that over, and what curl remove is designed to do is to remove the curl that can exist in a fibre. So I'm just going to chop this back a little bit so that I've now got a distinct curl. Now, anyone who's done a fair bit of splicing knows that these kind of situations cause a lot of trouble. You have trouble getting them into the cleaver. You need to have it all in line, and you're trying to get it to flatten out like that. So you have trouble stripping, cleaving, and you also have trouble getting into the machine. But the curl remove, if we put it curl down, let's check that I've got that correctly positioned. So now I've chosen this mode. So I've now got curl remove. I'm going to start. It's a very short program, and you can actually build it into the workflow if you have a few of them. So you'll see when it comes out, it'll be straight. And it'll only be straight for that section that you're working on, but that's all you need to get a good quality cleave that's efficient. So now that's finished its cycle. So now we pull this out. You can see that the end of it's now straight compared to what it was before. So after that's cooled, we'll then go through the stripping, cleaving, and lay it into the machine, and you can see that that's going to be much easier to work with. And to go back into the machine, we just change it back down to the 40mm continue. It wants me to change this back to here. This matches with the selector here. So there's the curl remove, and that's in the off position. And then we change this back to standard mode. Indicates we should change it across, slide that across, and now it matches that. Function in here is under maintenance, quick guide. We have a list of all the different typical functions that engineers need to take care of in the field. So it's changing electrodes, cleaning lenses, cleaning V-grooves, changing the battery. So let's have a quick look at cleaning the lens. So it says turn the power off, loosen the screws for the electrodes, pop the V-groove out. You need to keep in mind that this function is unique to the FITEL series, and it's only available on the Ninja and on the FITEL 179 at this stage. It allows you to have good access to the lenses, and it also allows you to, particularly in the case of the Ninja, which is a fixed V-groove splicer, to thoroughly clean the V-grooves, or if necessary swap them out. rather than having the machine sent back in for service. That's the a moistened alcohol tip on a cutting bod. And that's the task completed. So we'll go through that now. So what we'll do is turn the machine off. Move the electrodes. Typically the electrodes are cleaned every 1000 splices. Now we can remove the V-groove. So you can see the V-groove very easily comes out, and now we have excellent access to clean the lenses. We use a brush to blow out any of the bits and pieces that might have accumulated in there. These lenses are clean, so I won't clean them for the sake of the demonstration. We recommend only cleaning lenses if there's dirt on them. What typically happens is when people try to clean, they end up making the lenses worse because they can't actually see what's going on. So that's the V-groove lock back in place. That's the electrode back in place. So it's a toolless exercise to get the electrodes out and clean. The next one is I'll do a demonstration on cleaning the electrodes. So we have the electrode cleaning disc, which is a pink disc, which has got it's a rubber impregnated with oxides to act as an abrasive. Here I've got some old electrodes that we can play with. So there's a couple of things that we can do here. We can check the quality of the end of the electrode by using a magnifying lens. We're looking for it to be completely symmetrical and no damage to the tip, no etching. If the tip is good enough to maintain, what we do is we'll push it into the sidewall 3 or 4 times and twist it backwards and forwards half a dozen times. So what this does, it knocks the oxides off the tip. Now typically that's all that's required on the electrode. Gets wiped with alcohol to remove skin oils and then put back into the machine. Now I also have one here that has got quite heavy oxidization on the surface. Now you need to keep in mind that the oxidization on the surface will reduce the flow of energy. The energy is flowing down the surface of an electrode. So when you have oxidized electrodes, you can clean the oxidization off again with the same electrode cleaning disc.
How long does the electrode cleaning disc last?
Years and years. I have one here that has been on the service desk doing machines day in and day out for 3 years. It's also quite useful to put it on a flat surface. Makes it easier to control the electrode. So now I've got the oxides off that. Clean the tip. Again, 3 or 4. Then wipe the skin oils off. And now that's ready to be redeployed. To give you an idea of some of the problems that they have with lenses, I've got, you do not remove lenses from machines. So on this one here, it's going to be a little bit hard to see, but this actually has a smear on the surface. So by rotating it with light shining on it, you can actually get it to the point where you can see a smear on the face. And this one here is a fully cleaned one, so it's all bright and shiny. So it's not until you've actually had a chance to compare and have very good light that you can actually tell whether the lenses are fully clean or not. You can see it there. See that smear? Yeah, that view there. Yep, that's it. Whereas this one here will be fully clean. So getting good light shining off lenses means that you have a chance to clean them properly. If you can't get good light on them, don't try and clean them. We do not blow on the machine with our mouth. We only ever use a good quality blowing brush. This one here puts out plenty of power that allows you to clean the inside area very quickly and efficiently without any spittle coming from your mouth if you were to use your mouth. This particular series as well, just out of interest, you'll see that in the lid here we have no mirrors. So this reduces the maintenance on the machine. The LEDs used for backlighting used to be installed in the base, and mirrors used to be in the lid. Now the mirrors have been removed and the LEDs have been inserted in the lid. So while we're rotating this, we can see we've got a USB connection here for downloads. We have a power port here, and this will take from 11 through to 25 volt DC. We have a camera mount, so when we want to mount this, these are easily removed. It's only a matter of a screw, and we can remove these and we can mount this onto a flat surface that can be on a tray that can be mounted. We have a stand that's removable with silicone put on the sides here so that there's no damage to fibre if it happens to have got caught. We also have this tray, that again easy to remove, and we also have underneath here we have the battery and the Wi-Fi dongle. So in here we have the Wi-Fi dongle that we can hook this up with an app on a phone. Plus we also have the battery that we can remove and replace if it's required. So we've increased the power and reduced the cost. These holders can be removed, and you can use a drop-in clamp system. Plus we also have these two buttons here that allow for extra grip of the fibre. In some cases we have loose and semi-loose. So typically your tight buffered fibres, you're stripping 5 mil at a time, and it also takes it straight down to the 125. This particular one is leaving the 250. If I can get 30 or more mil off in one hit, then we can call that loose buffered. So this one here is now behaving like a semi-loose. So I can get 5 to 10 mil off without too much trouble from it. And then I still end up with the 250 that needs to be stripped off. So that would qualify as a semi-loosed fibre. This one here, this grey one. So that would be semi-loose, because I can get 30 mil off at a time. So if you can get 30 mil off at a time, the problem that you're going to have is that the fibre will piston. So in this particular case, what we do is we strip another, so we step it. So now I've got 125, 250, 900, and then when we put it into the machine, we allow one button to sit on the 250, another button to sit on the 125, 250 and 900.
What's pistoning?
Pistoning is where the fibre will push back, or backwards and forwards in the machine
As it's feeding it for splicing.
So what we do is we strip this in such a way that we can put the fibre in and end up with one button sitting on top of the 250 and another button sitting on top of the 900. So in this position, the fibre doesn't piston, it stays in place. Setting up a workflow involves having the equipment in a convenient place so that it's easy to work with. And in the case where you might be working with different positions for what you're working on. So if you're working on a large enclosure, this is going to be central and easy for you to work and with, and the workflow will go from splice, heat shrink, cooling, and into the splice tray. This is assuming that we've got quite a large container at the back here that we're organising. The other mode of work is one that is often used in, I'm just going to reverse the monitor on this so that it then goes upside down. So the other style is to have the machine sitting like so, and in this particular scenario what you're doing is you've got a very small compact tray that you're trying to work on here, so like component assembly and such, and this way we've got the workflow: splice, heat shrink, cooling tray, and assembly. So this is a very common production line environment or small cassettes. We have a clear display of the battery life that's on there. Currently we've got the Wi-Fi symbol, the splicing program, heat shrink program, the heater function, and the play button. So in the Splicer program there's a long list. So you've got auto, this is typically used for multi-mode, single mode and dispersion shifted fibres. So if you have a rack of multi-mode and single mode fibres in, say, in a data centre, by having auto, it'll automatically select multi-mode or single mode. It'll also show you an error if you've got the wrong pigtail being spliced onto the wrong fibre.
If you're not sure what fibre you've got, how do you find out?
Yeah, typically we would go up into tools. So if you go up into tools, you do fibre measurement, it'll give you a full readout of the the fibre. So we've got 3 pages here. So you'll end up with the core width, which is a giveaway as to what type of fibre you're working on.
Yeah.
It also gives you X and Y measurements, and these should be the same for the right fibre, and then they likewise on the left fibre the X and Y should be very similar. If they're not similar, it's an indication of dirt on the lens. So in dissimilar fibre splicing we would use, well, it depends on the type, we have a huge range. So we'll just scroll down through here, you can see we've got 652 to 657, so there's your standard single mode to bending sensitive single mode. We've got single mode to multi-mode. It's an unusual splice, but is required from time to time. Single mode to non-zero dispersion shifted, non-zero to single mode, multi-mode dispersion shifted, true wave, leaf, attenuation mode. This one's a fairly simple one to set up, where you want to splice in to a pigtail a 5 dB loss, and then install that so that you don't have to buy an attenuator for that particular application. BBXS is also a very common fibre, particularly here in Australia. So BBSX to single mode and BBX to BBSX is a very, very common splice requirement. Easy Bend's another trade name. It handles the 80 micron fibres, high NA, whole screed of different types of fibres. So now we're up to 64, and so that's what we've got built into the machine, 64 programs that are ready to roll on almost any type of fibre. This particular type of machine is the kind of machine that gets used in labs, out in the field, for telco splicing, for mining. At the top end of the field game is splicing your submarine cable to land cable when a intercontinental fibre is brought onto land. This is the kind of machine you use for that application. So on the heat shrink side, yeah, I've actually repositioned them. So the normal run is from 1 through to, what's that go up to? Goes up to 22. So they're pre-installed. So their SoC is splice-on connectors. Continuous, when you're working in very, very cold environments, you just have the heater continually running. Mini splicers to curl remove. Any one of these that you might be interested to have more readily available than having to scroll down, you can go through this this scenario here where we can get hold of it, copy. I store my common use ones up at the top here, edit, and then paste. And so now I've installed it there.
Quick access.
For quick access. So it gives me my common 40 and my curl remove. You can do the updates either via a phone or via the USB. Settings, we have complete control over pretty well all settings on the machine. Arc check is typically done when you've got a large project on. So if you're working, say you set up in the morning and you're going to be doing 100, 200 plus fibres, then doing an arc check is an obvious thing. Clean the machine, make sure everything's all good, do an arc check, make sure everything's ready to go. If you're only doing 12 splices a day, you only need to check the arc perhaps once a week or once a fortnight. So the arc check is relevant to the kind of work that you're doing and how many fibres you're putting through. Also have a manual splicing mode. in semi-automatic, it'll bring it all in and get it all ready to go. This one's good when you're got a very, very short length of old fibre that's difficult to work with. Rather than leaving the machine to try and wrestle with it, knowing that you're going to have image errors and all sorts of stuff because of the corroded surface, you can take it into the manual mode and feed it and look after it and make sure that you get the kind of splice that you want. It gives you semi-automatic, brings everything all together, but then gives you complete control over any function you wanted to control. This self-check, the machine actually does a self-check when it first starts up. So you start off with no fibres in it. It'll do a full check of all the motor movements and the condition of the optics. You can hear all the motors running. So it's doing that automatically each time you turn the machine on. But if you do have a problem that you want to check out, you can put it into that mode just to see that everything's all working properly. The screen's also a daylight screen, so it can handle being out in full daylight, and you'll be able to see the fibre you're working on. It's a tough screen, but it's also designed for people that are wearing gloves to still be able to get various functions to work. So it's a very, very cleverly designed screen to be tough and be able to handle touch in a working environment. Yes, anyone who's used a FITEL before will be very comfortable with this layout. This menu is also the same type of layout. What we did with the heater one where we copy, you can do the same. You can do the copy and edit. These ones with a padlock on them, you can't actually edit those. What you have to do is copy them to somewhere else. So if I was to open up this one here and do some edits to it, so I was to change the arc duration. It won't let me change it. So it's completely protected. So your important programs are locked. You can see all the ones with a lock on them. So you know that someone can't just go mucking around with a program. If it's got a lock on it, it's safe. It's been, it can't be changed by someone who doesn't know what they're doing. But if you do want to use that as a base program, it's only a matter of doing a copy, scroll it up to a new position and paste. And now I can edit, then edit. So I can change the arc duration. I can put in a new figure here. And I can change the name of it. So I can tailor this program to suit whatever exotic fibre that I'm wrestling with. And then I have a choice to overwrite parameters or no, I can just let it disappear so it stays standard. So you can do a lot with the machine. Spend some time with it, get to know it, you'll enjoy it.